So in the previous video, we already finished learning 4.1 estimated regression sample model, and we learned how the estimated simple linear regression equation should look like, which is y hat equal to b0 plus b1x. So the value b0 and b1 will be able to obtain by using the regression analysis on Excel. And so we also learn how to interpret the slope b1. So that is if x increased by 1 unit and y will correspondingly increase by b1 unit. And so that is the estimated regression sample model. So after we finish this step, and we're going to move on to the next step called 4.2, testing the quality of the sample model. So why we need this? Because after we estimated our estimated regression equation, so we basically understand for the scatter plot, so what is the trend line should look like. However, we won't be able to know if the trend line will be able to broadly used to representing the sample data we collected. So basically, we try to look at if that trend line can be do a good job to predict the scatters in your scatter plot. So that's why when we are working on the step 4.2, we also call it measuring the goodness of fit. We try to look at how this linear model can fit in the data. So that's why we call it goodness of fit. So in order to understand this statistic we're going to use to measure the goodness of fit, and we have to introduce this equation. And so the following equation will be a hold for all the regression models, So this equation consists of three components: SST, SSR, and SSE. So SST stands for the total sum of a square. So that is the total unknown for the y variable we won't be able to explain without using the regression model. And the SSR is the total unknown, but that portion can be explained using that simple linear regression equation. And SSE is sum squared due to error. So that part will be the part even we have the regression model, we won't be able to use to explain the unknown of the regression model. So why that we call it SST? Because without information from x variable, we always can calculate the mean of y. So the differences between each observation to y, that is the uncertainty involving the y variable. So how can we answer, or how can we predict those uncertainty? That's why we rely on the regression model. So that's why we will have this SSR. So basically the SSR is measuring the differences of estimated y value using your regression model and the mean value of y, which you're already able to calculate without your x variable. So these differences will be able to estimate it using your estimate regression model. And SSE, however, you have the regression model, and you will be able to obtain the value for y hat, estimated y value, but you won't be able to predict the exact value of yi. So that's why. And the SSE actually will be the component you will never able to explain, even you have the regression model. So that's why the total unknown about y will equal to the portion can be explained by the regression model, SSR, plus the portion you won't be able to use your regression model to explain the model. So why these three equations so important? Because this is the base of the statistic we're going to learn pretty soon that can be used to measure the goodness of fit on the model. So keep in mind the goodness of fit or measure the quality of the sample model. We try to see how well the regression model can do to predict the unknown of the y variable. So which means if we have larger SSR, smaller SSE, that means our model is good. So larger SSR, smaller SSE, we will have a good model. And so instead of calculating both statistics, so statistician actually create a ratio. So what they did is both sides of this equation will be divided by SST. So SST divided by SST will equal to 1. And SSR divided by SST plus SSE divided by ST. So now you can see the 1 equal to SSR divided by SST plus SSE divided by SST. So you notice that the SSR SST, SSE. When we do those three component calculation, they all square, which means none of them can be negative. So SSR divided by SST will be a positive value. Also, non-negative value, as well as SSE divided by SST will be a non-negative value. So two non-negative value adding together has to equal to 1. So that means the ratio of SSR divided by SST has to between 0 and 1. So SSR divided by SST will be between 0 and 1. So now I give you 2 seconds, think about. So if this ratio SSR divided by SST very close to 1, does that mean the model fitting the data well, or the model fitting the data bad? Yes. So the answer is the model fitting the data well, because as I said, SSR is the portion you can use your regression model, is the portion of the unknown that you can regression model to analyze it. So the larger, the better your model you have. So obviously, if this ratio SSR divided by SST is larger, that means the model is better. At the same time, I just mentioned SSR divided by SST has to be larger and equal to 0, smaller and equal to 1. So that's why if this ratio close to 1, so we actually will have a good model that fitting our data well. So we actually, statistician actually name this ratio SSR divided by SST a new name. So the new name is called a coefficient of determination. So usually we call it R square. So using SSR divided by SST. So that's called the coefficient of determination. Keep in mind, we work on your homework and work on your attendance check practice question. So this R square we are using to check the goodness of fit, and also we are also use it to see using R square to measure the quality of the sample model. So the larger the value is, the better. So after you obtain the R square, how you should interpret it. Keep in mind, in this class, we're not only learning how to analyze the regression model, but also we try to learn how to interpret our results. So after you receive the R square, I will show you pretty soon where you can find from Excel. And so how you're going to interpret R square. So the interpretation for the R square should follow this following interpretation formula. So first of all, you're going to convert R square to percentage. So as I said, R square always smaller than 1. So you always can convert to a percentage that is less than 100%. So R percent of variation in Y variable can be explained by the regression model. So basically, this interpretation help us better understanding why we are needing what the regression model really trying to do. So the regression model is not trying to predicting the mean value of Y variable. Actually, the regression model is trying to predicting the unknown part of the Y variable. Without this regression model, so those unknown has a huge value. After we have the regression model, that R will become smaller. So we're gonna look at the same handout I asked you to use, and hopefully you can find it. And if not, you can download under the lecture. And the file is called chapter 14 handout, chapter 14 on handout. So on this handout, and you will be able to see the table we already seen last time. So this is 3 pages, 3 tables. So it's on the page 1 of that handout. So last time we already identified where to find the B0, which is here, and where to find the B1 for the simple estimated simple linear regression model. So in this video, we're going to look at where to find SSR, SSE, SST, and our and also where to find R squared that we're going to use to measure the goodness of fit of the model. So first of all, look at the second table. It's called ANOVA table, ANOVA table. And then under ANOVA table, there is one column called SS. So SS. So focus on this SS column. What are 3 values? 3 values. So the question is, which one is SSR, SST, SST? So you just need to remember the name of each term on the slides. So the SSR is some square error, can be expanded by the regression model. So if you look at the first row here, so the first SS is corresponding to regression. So that is some square error that can be expanded by regression. So obviously the first value on the SS is SSR. And then the second value is related to the residual. We can come back later, but look at the last one, SST. total. So so on the slides we learned that there is SST, stands for sum square total error. So obviously the last value in this column, SS total, will be corresponding to SST. So the only one left is the middle one. It's called actually it is SSE, sum square error. But here we actually notice that it's called residual. So actually in the statistical world, we believe residual is the estimate for the error. Remember, the error term you won't be able to observe, but you definitely can estimate it. So that's why on Excel they use the term residual instead of error. So the SSR, SST, and SSE you can find from Excel output. So when you work on homework, please don't try to calculate by yourself because it actually is pretty complicated. So after we learn where to find SSR, SSE, and SST, so now we're going to look at where to find R square. So the R square, it is in the first table. So make sure you mark on your handout. So in the first table called regression statistic, and you will notice that there is one value called R square. It's in the second row. So here you got 0.7201. So that is the R square you will use to measure the goodness of fit of the model. And so after you find this value, and you still need to interpret the result. 0.7201. So first of all, you're going to convert to percentage. 72